6 examples of derivations using universal out. Having figured out the universal out rule, we next look at examples of derivations in which this rule is used. We start with the arguments at the beginning of section 3. Example 1 1xfxhxpr2fc prairie 3hcdd4 fchc1, 05hc2, 4. Example 2 1xsxpxpr2 xsx and pxdxpr3 sm prairie 4 decimeters dd5 smpm1, 06 sm and pmdm2, 07 pm3, 5, 08 sm and pm3, 7, ni 9 decimeters 6, 8. The above two examples are quite simple, but they illustrate an important strategic principle for doing derivations in predicate logic. Reduce the problem to a point where you can apply rules of sentential logic. In each of the above examples, we reduce the problem to the point where we can finish it by applying arrow out. Notice in the two derivations above that the tool, namely, universal out, is specialized to the job at hand. According to universal out, if we have a line of the form VFV, we are entitled to write down any instance of the formula FV. So, for example, in line 4 of the first example, we are entitled to write down FAHA, FBHB, as well as a host of other formulas. But, of all the formulas we are entitled to write down, only one of them is of any use, namely, FCHC. Similarly, in the second example, we are entitled by universal out to instantiate lines 1 and 2 respectively to any name we choose. But of all the permitted instantiations, only those that involve the name M are of any use. To say that one is permitted to do something is quite different from saying that one must do it, or even that one should do it. At any given point in a game, say, chess, one is permitted to make any number of moves, but most of them are stupid supposing one's goal is to win. A good chess player chooses good moves from among the legal moves. Similarly, a good derivation builder chooses good moves from among the legal moves. In the first example, it is certainly true that FAGA is a permitted step at line 4. But it is pointless because it makes no contribution whatsoever to completing the derivation. By analogy, standing on your head until you have a splitting headache and are sick to your stomach is not against the law. It's just stupid. In the examples above, the choice of one particular letter over any other letter as the letter of instantiation is natural and obvious. Other times, as you will later see, there are several names floating around in a derivation, and it may not be obvious which one to use at any given place. Under these circumstances, one must primarily use trial and error. Let us look at some more examples. In the previous section, we looked at an argument that was obtained by a misapplication of universal out. As noted there, the argument is valid, although it is not an instance of universal out. Let us now show that it is indeed valid by deriving the conclusion from the premises. Example 3 1xfxxgxpr2 xfx ga cd3 xfx is 4 ga dd5 xgx1, 3, 06 ga 5, notice, in particular, that the formula in 2 is a conditional, and is accordingly shown by conditional derivation. You are, of course, already very familiar with conditional derivations. To show a conditional, you assume the antecedent and show the consequent. The following is another example in which a sentential derivation strategy is employed. Example 4 1xfxhxpr2 hbpr3 xfx id4 xfx is 5 dd6 fbhb1, 07 fb4, 08 hb6, 7, 092, 8. In line 3, we have to show xfx. This is a negation, so we use a tried and true strategy for showing negations, namely indirect derivation. To show the negation of a formula, one assumes the formula negated and one shows the generic contradiction. We conclude this section by looking at a considerably more complex example, but still an example that requires only one special predicate logic rule, universal out. Example 5 1xfxyrxypr2 xyrxyzgzpr3 GB pr4 phi d5 phi 6 dd7 phi yray1, 08 yray5, 7, 09 rab8, 010 yray zgz2, 011 rab zgz10, 012 zgz9, 11, 013 GB 12, 014 3, 13. If you can figure out this derivation, better yet if you can reproduce it yourself, then you have truly mastered the universal out rule.